You know, math anxiety is an incredibly common thing. And honestly, when you're staring down a jumble of variables, squared numbers, and equal signs, it is so easy to just feel totally overwhelmed. But listen, I'm making a bold promise to you right now. By the time we wrap up this explainer, you are going to be equipped with absolutely every tool you need to conquer quadratic equations. We're skipping the fluff today. We are just giving you the pure, structured knowledge you need to solve these things with total confidence. So, think of this explainer like a hero's journey. You're stepping into this complex world, and our mission today is to collect the exact mathematical weapons, the ultimate cheat codes, really, needed to defeat any quadratic monster that crosses your path. We're going to make this easy. We're breaking it down into simple visual steps. Okay, here's our roadmap for today. First, the quadratic blueprint. Second, unlocking the roots. Third, the factorization method. Fourth, the discriminant decoder. And finally, number 5, the ultimate formula. Section 1, the quadratic blueprint, recognizing the monster. Right, so before we can actually defeat this monster, we have to know how to recognize it in the wild. A quadratic equation is simply a polynomial equation of degree 2. And that phrase right there, degree 2, that is the defining characteristic. It just means the absolute highest power of your variable, let's call it x, has to be exactly 2. So you're always going to see an x squared term. If the highest power is a 3, or hey, if it's just a 1, you are not looking at a quadratic equation. It's really that simple. Now, here's the golden rule of standard form, which is ax squared plus bx plus c equals 0. The coefficient a absolutely cannot be 0. Why? Well, think about it. If a is 0, 0 multiplied by x squared is just 0. That defining squared term vanishes completely, and without it, your equation basically devolves into a simple linear equation. So a can never be 0. B and c, sure, they can be whatever, but a is off limits for 0. Section 2, unlocking the roots, finding the passwords. Okay, now that we know how to spot the equation, what's our actual goal here? The goal is to find the roots. I want you to think of roots as the secret passwords that unlock the equation. They're the specific numerical values for your variable x that you can plug right back into the equation to make it perfectly balanced, meaning the left-hand side is going to exactly equal the right-hand side, which is typically 0. And guys, here is an absolute unbreakable rule of math you've got to remember. Every single quadratic equation has exactly 2 roots. Literally always. Never 1, never 3. There are always exactly 2 values that will perfectly satisfy the equation. Now, sometimes they might be the exact same number twice, but fundamentally, there are 2 roots. So, how do we actually find them? Section 3, the factorization method, weapon 1. The very first mathematical weapon you can use is factorization. You might know it as middle term splitting. Now, I know this can seem incredibly complex at first glance, but we can actually distill it down into 3 clean, actionable steps. First, always arrange your equation into standard form. That's your x squared term first, then the x term, then the constant. Second, you have to play a little number puzzle. You need to find 2 magical numbers that add up to your middle coefficient b and multiply it together to equal a times c. And third, once you find those 2 numbers, you literally split that middle x term into 2 pieces, group them together, and pull out the common factors. Okay, here's a massive cheat code for that number puzzle I just mentioned, because figuring out the plus and minus signs is exactly where most people get stuck. Here's the hack. If your target product is negative, you instantly know one of your numbers must be negative. But which one? Well, look at this sum you're aiming for. If the sum is positive, then the smaller of your 2 numbers takes the negative sign. If the sum is negative, the larger number takes the negative sign. Honestly, this eliminates so much trial and error. It's a total game changer. Moving right along to section 4, the discriminant decoder, the crystal ball. Sometimes we want to know what we're walking into before we do all the heavy lifting, right? Enter your mathematical crystal ball, the discriminant. It's represented by a capital D, and it's simply b squared minus 4ac. Notice how it relies perfectly on the exact same a, b, and c coefficients we talked about in our quadratic blueprint. By isolating these coefficients and plugging them into this tiny little equation, we unlock some immense predictive power. So here is your essential cheat sheet for reading that crystal ball. If your decalculation results in a positive number, anything greater than 0, your equation is going to have 2 real distinct roots. That means 2 completely different numbers. If d is exactly equal to 0, your two roots will be real, but they're going to be equal to each other. But, and this is a big but, if d is a negative number, your equation has no real roots at all.
The crucial takeaway here is that calculating d should almost always be your very first step. Think of it as sending a scout ahead into battle. If the scout comes back and says, hey, d is negative, you stop right there. You don't even need to try and solve it because there are no real roots to find. You are only clear to proceed and solve the whole equation if d is positive or 0. It's a huge time saver.
Finally, Section 5, the ultimate formula, Weapon 2. Let's transition to the absolute foolproof tool in our arsenal, because let's be honest, sometimes middle-term splitting gets way too confusing. Maybe the numbers are massive, or there are messy square roots involved that make guessing basically impossible. When factorization fails you, this is your ultimate, universal backup key. Sridharacharya's formula will conquer literally any quadratic equation you throw at it. Presenting the magnificent quadratic formula. It tells us that x equals negative b plus or minus the square root of d, all divided by 2a. Now look closely at that square root for a second. Do you see d? That is the discriminant we literally just learned how to calculate. It slots perfectly inside the square root, showing exactly how all these mathematical tools are just beautifully connected to each other. Now, using this formula without making silly mistakes requires following a pretty strict step-by-step procedure. Step 1. Identify those a, b, and c coefficients. Step 2. Calculate your discriminant, d, to make sure real roots even exist in the first place. Step 3. Plug your d value along with b and a straight into the formula. And step 4. Because of that plus or minus symbol, you actually split the math. You solve the whole thing once using the plus sign, and then you solve it again using the minus sign. That is exactly how you get those two roots. To make absolutely sure you never fail at this, you've got to avoid a few common pitfalls. First, always, convert your messy equation into standard form before you pull out your a, b, and c. When you do pull those coefficients out, you have to take the negative signs with them. If the equation says minus 5x, your b is negative 5, not just 5. And lastly, look at the denominator of our ultimate formula, 2a. Dividing by 0 is a mathematical sin, which proves perfectly why our very first rule today was that coefficient a cannot 0. It all comes full circle. Well, you've done it. You have collected every single weapon you need. You understand the standard form blueprint. You know the factorization cheat codes. You can literally predict the future with the discriminant, and you wield the ultimate formula as a flawless backup plan. Like we said at the start, math isn't something to be anxious about. It's honestly just a puzzle, and you now hold the exact codes to solve it. So my final question to you is, now that you have the ultimate keys, what quadratic equation will you conquer next? Thanks for hanging out and learning with me on this explainer, and remember, keep that structured focus sharp.